Welcome to Integration Excellence, the podcast around enterprise integration and interface management. We explore topics related to integration in the SAP world and beyond. My name is Adam Kivon. I am an SAP integration expert, book author, trainer, and founder of White Paper Interface Design. Enjoy!
Imagine a global logistics company for a second. We're talking about 3 million packages currently in the air.
Right, crossing oceans and continents.
Yeah.
Massive scale.
Exactly. And suddenly, the system tracking those cargo planes it stops talking to the system managing the landing strips and the warehouse bays at the destination.
Which is a nightmare.
It is. In a
Yeah.
matter of minutes, you don't just have a minor IT glitch. I mean, you have a multi-million-dollar catastrophe on your hands.
Oh, absolutely. Planes burning fuel, trucks idling.
Supply chains backing up across the globe. And, the first question is always, why? Did a hacker infiltrate the mainframe? Did a server catch fire?
Usually no.
No. It happened because an undocumented digital bridge, a simple software connection built 5 years ago by some developer who doesn't even work there anymore, just silently broke.
Yeah, and nobody even knew it existed until the damage was done.
Right. Have you ever considered how terrifyingly fragile the invisible digital infrastructure running our world actually is?
I mean, it really is the defining vulnerability of the modern corporate era. We often operate under this illusion that enterprise technology is this perfectly engineered, frictionless machine,
Yeah, it's all just magic in the cloud.
Exactly. But the reality, the digital architecture of most global corporations resembles this sprawling, chaotic metropolis. New skyscrapers are being built on top of, ancient, crumbling underground foundations.
Wow. That's a terrifying image.
It is, and when those hidden connections fail, it's rarely just an isolated technical hiccup. It is an immediate threat to business continuity. I mean, if the underlying systems cannot communicate, the business simply ceases to operate.
So it's a precipice that major organizations walk every single day.
Every single day, yes.
Well, today's deep dive is dedicated to pulling you, our listener, back from that precipice. We are going to explore the monumental challenge of conquering the chaos of enterprise IT integration.
Which is such a critical topic right now.
It really is. Our mission today is to dissect how the world's most complex organizations are untangling these massive digital webs. They're trying to achieve what the industry formally calls integration excellence.
Right. Moving from chaos to excellence.
Exactly. And more importantly, we are going to look at how they manage to govern and document this critical flow of data without, and this is key, without resorting to armies of consultants and thousands of hours of manual mind-numbing drudgery.
Yeah, because that manual approach just doesn't work anymore. It is a critical shift in how we approach enterprise architecture. For decades, the focus has solely been on building the connections, just getting things connected.
Right. Build the bridge, move on.
Exactly. But now, the absolute imperative is governing them.
So to guide us through this labyrinth, we are pulling from a dense stack of sources today. Technical white papers, detailed product fact sheets, and official architectural blog posts from a German company called whitepaper.id, GmbH.
Excellent sources.
Yeah, they're incredibly detailed. Specifically, we are diving deep into their turnkey solution, which is the WHINT Integration Cockpit.
Right, the WHINT cockpit.
Yeah, and looking at the scale of the problem they are addressing here, I mean, it's staggering. Managing the synchronization between my own smartphone and my laptop occasionally drives me up the wall,
Oh, I know the feeling.
So scaling that up to hundreds of thousands of asynchronous connections across a multinational conglomerate, it just feels like an impossible task.
Well, to truly grasp the gravity of what the WHINT Integration Cockpit actually does, we have to deeply understand the environment it was built to tame.
Okay, set the scene for us.
In enterprise architecture, we refer to this as the integration landscape. And these landscapes, they aren't just growing, they are mutating.
Mutating.
Yeah, we are seeing this exponential complexity driven by just an insatiable business demand for speed and connectivity.
Okay, let's ground this for you, the listener. When the architectural white papers talk about an integration landscape, and specifically they use the word interfaces, what are the actual mechanics we are looking at here?
Well, at its core, an enterprise rarely, if ever, runs on a single software platform.
Right.
Like a massive manufacturer might rely on a heavy-duty SAP ERP system, that's enterprise resource planning, to handle the intense mathematical heavy lifting of their global finance and supply chain.
That's the beating heart of the company.
Exactly. But then Their human resources department might demand a specialized agile cloud application like Workday.
Makes sense.
And their sales teams, they might absolutely refuse to use anything other than Salesforce for customer relationship management.
Right, so you have all these different islands.
Exactly. And an interface is that critical digital bridge constructed to allow these entirely distinct, often incompatible systems to speak to one another. It's the translation layer and the transport mechanism.
Okay, so if the sales team closes a massive deal in Salesforce, an interface is what actually translates that action into a manufacturing order in the SAP system,
Yes.
ensuring the factory floor actually starts building the product.
That is the perfect real-world example. And over the last 10 to 15 years, the architectural philosophy has drastically shifted. We've moved away from massive, centralized, monolithic systems toward hybrid architectures.
Meaning a mix of old and new.
Exactly. You now have legacy, on-premise middleware, literally servers physically sitting in a corporate basement that have been running reliably for 20 years, operating directly alongside highly ephemeral modern microservices hosted in the cloud.
Wow.
And because the business demands constant integration of new cloud apps, the raw volume of these interfaces is skyrocketing. We're talking into the thousands or even tens of thousands for a single enterprise.
The sources are incredibly explicit about the stakes here, too. They point out that when these interfaces fail, or I think more insidiously, when they are poorly designed from their inception, the consequences ripple outward instantly.
Without a doubt.
We are talking about severe supply chain delays, incorrect order acceptances leading to massive customer churn, and major financial compliance violations.
Which introduces one of the most critical concepts in software engineering, which is technical debt.
Okay, break that down for us.
Let's explore how this debt actually accrues in an integration landscape. Imagine the chief marketing officer comes to the IT department and says, we just bought a new cloud-based analytics tool, and we need our customer data flowing into it by next Friday for a major campaign launch.
The classic unrealistic Friday deadline.
Exactly. So what do the integration developers do? They scramble. They don't have time to design a highly resilient, globally standardized, beautifully documented interface.
They just need it to work.
Right. They build a quick, custom point-to-point connection. They might hard-code some passwords, skip the error handling logic, and just push it live.
Yikes.
And it works for that Friday. The marketing campaign is a success, but that quick fix is now a permanent fixture in the IT landscape.
Right, and it's totally undocumented.
Undocumented, doesn't follow corporate security standards, and the only person who knows how it works is the junior developer who built it at 2 in the morning.
Oh, man.
Fast forward 5 years, multiply that scenario by 1,000, and you have a crippling amount of technical debt.
I want to build on that city analogy we touched on earlier. So think of a massive, sprawling metropolis. The interfaces we are discussing are the physical infrastructure, right?
Yes.
The highways, the suspension bridges, the subterranean water pipes, the high-voltage electrical grid connecting all the different boroughs.
Exactly.
What we are describing with this technical debt is a scenario where a city has completely lost the blueprints to its own underground infrastructure. Like, they know the water is flowing, but they have absolutely no idea which pipe it's flowing through.
That's spot on.
And the absolute danger is that the next time construction crew starts digging to build a new subway line, they're going to blindly sever a main power artery.
Is that essentially the daily reality for these massive corporate IT departments? Like, they have constructed this incredible digital city, but they've just lost the map.
That analogy holds up perfectly under scrutiny. And to make it even more precarious, the city planners aren't just missing the map. They are under immense pressure to continuously build new underground tunnels, while the old, undocumented ones are actively carrying high-pressure water.
That's insane.
It is. This invisible spaghetti of undocumented interfaces is the root cause of why major corporate digital transformations fail so spectacularly.
Because you fundamentally cannot transform, migrate, or upgrade a system if you don't even know what it is attached to.
Precisely. Let's say the board of directors mandates a strategic move to the cloud to save on data center costs, right?
Happens all the time. Yeah. The IT team wants to decommission an old, expensive on-premise server, but they are paralyzed. They can't pull the plug because they have no idea how many critical business processes silently rely on that server to route data.
If you turn it off, does the payroll system crash?
Does the factory floor grind to a halt? Exactly. Without a meticulously maintained map, enterprise architecture basically devolves into a terrifying, high-stakes guessing game. You cannot govern a ghost, and you absolutely cannot optimize it.
So if the core issue dragging down global enterprises is this lack of a clear, standardized map, this invisible spaghetti problem, how do companies practically solve this? Because my immediate thought is that you would have to hire an army of specialized engineers to manually read through millions of lines of code.
Yeah, system by system.
Right, just to figure out what is talking to what. And that sounds like a project that would take 5 years and cost an astronomical amount of money.
You are describing the traditional, painful reality of enterprise IT audits. Historically, mapping an integration landscape involved massive Excel spreadsheets, endless cross-departmental meetings, and thousands upon thousands of manual consulting hours.
Ugh, spreadsheets.
And the truly tragic part of that manual approach, the very second that massive spreadsheet is finally completed and saved, it is already out of date.
Because the landscape shifted while you were mapping it.
Exactly. A new client app was connected, an old server was patched. Manual documentation in a dynamic digital environment is basically a Sisyphean task.
This is where our source material introduces whitepaper.id GmbH and their specific approach to solving this exact crisis.
Yes. The company was founded in Germany in 2014 by Adam Kiwan. And what is notable about their pedigree is their deep historical focus on SAP middleware.
Which is everywhere.
It is everywhere, and SAP is notoriously complex. It forms the backbone of the world's largest companies. Their stated mission is to guide these highly complex organizations away from that manual chaos and toward a state of integration excellence.
And their primary vehicle for achieving this is the WHINT Integration Cockpit. The technical fact sheets describe this as a SaaS-based software as a service central control center.
Right.
It's custom built to manage the exact complexity we've just spent time outlining. It essentially acts as both an automated robotic cartographer and a strict architectural governance engine.
The word that jumps out repeatedly in their official documentation is turnkey. Now, in the realm of massive enterprise software where you are dealing with multinational corporate infrastructure, turnkey is a dangerous word to throw around.
I was going to say nothing is ever turnkey in enterprise IT.
Exactly. Usually, purchasing an enterprise tool is just step one of a grueling 18-month implementation and customization nightmare. But the WHINT Cockpit claims a radically different, almost friction-free deployment model.
I am so glad you brought that up because I have to push back hard on one specific claim in the sources.
Okay, let's hear it.
The fact sheets state that the setup of this massive governance engine is completed within a few hours. Now, anyone who has ever worked inside a large corporation knows that IT projects usually take 3 months just to get a kickoff meeting scheduled with the security team.
That's very true.
Let alone deploying a tool that maps the entire corporate data flow. How is it physically, architecturally possible to deploy a central control center across a global landscape in just a few hours? What are they leaving out?
It's a very necessary skepticism.
Yeah.
I mean, if they were installing traditional monitoring agents, little pieces of software that sit on every single server to intercept and copy data traffic, you'd be absolutely right.
That would take a year of security reviews.
Easily. The reason the WHINT Cockpit can be deployed in hours and why they can offer a risk-free promise where they simply uninstall it in minutes if you don't license it is fundamentally due to its non-invasive architecture.
Okay, explain how a non-invasive architecture actually works in this context.
Well, it operates as an automated overlay. The WHINT Cockpit does not sit in the middle of your network traffic. It doesn't reroute your business data.
So it's not a choke point.
Exactly. Instead, it securely connects to the management APIs, the pre-existing administrative backdoors of your various integration platforms. It uses standard, highly secure authentication to essentially log in as an administrator, look at the configurations, read the metadata, and pull that descriptive information back into its own engine.
Interesting.
It's the difference between setting up a roadblock to check every car's trunk versus just looking at the city planner's public registry of which roads exist.
So it's reading the blueprints that are already hidden inside the systems rather than trying to reverse engineer the actual traffic flow on the highway?
Precisely. It is observing and cataloging the configurations that are already natively there. Because it relies on standard, pre-approved API endpoints, the security and network teams don't have to punch massive new holes in the corporate firewall.
There is a quote in the source material that contextualizes the speed really nicely. Andreas Hammerhausen, the head of application development at Fern University in Hagen, which is Germany's largest university, specifically praises the comprehensive support and long-term partnership with Mr. Kiwan.
Right.
It highlights an important nuance, I think. The software itself deploys rapidly in a few hours, but the goal isn't just a quick, superficial audit. The goal is establishing a long-term foundational shift in how the organization governs its landscape.
And you cannot govern what you cannot see. Which brings us to the first massive capability of the WHINT Integration Cockpit. It's the absolute prerequisite for everything else the tool does, figuring out what is actually running in the dark corners of the IT environment.
The sources refer to this as automatic discovery and central inventory. And looking at the technical specifications, the breadth of systems it can interface with is incredibly wide.
It has to be wide to be valuable. I mean, an inventory tool that only maps half of your city is arguably more dangerous than having no map at all because it gives you a false sense of security.
That's a great point.
The WHINT Cockpit covers the heavy SAP environments comprehensively. We are talking about discovering interfaces built on the modern SAP integration suite, older SAP process orchestration systems, and even legacy SAP ABAP backend connections utilizing classic protocols like IDOC, OData, and SOAP.
Those are heavy traditional enterprise protocols, but the modern IT landscape isn't just SAP anymore, right?
Oh, far from it.
The fact sheet stresses that it goes way beyond the SAP ecosystem. It automatically discovers interfaces on Microsoft Azure integration services like Logic Apps and Azure Service Bus. It connects to MuleSoft, Solace, and even Confluent Kafka event streams.
Yes.
Let's pause here, because if you have a traditional SAP IDOC system, which is a very rigid, old-school way of sending a batch of financial data, and you have a modern Confluent Kafka system, which is a real-time continuous stream of events, how does one single tool comprehend both of those entirely different paradigms?
That is the exact architectural hurdle that makes manual mapping so difficult. An SAP IDOC and a Kafka stream are fundamentally different philosophies of data movement. The genius of the WHINT Cockpit is an internal mechanism the sources call system and object mapping and harmonization.
Harmonization. That implies taking chaotic, different things and forcing them to sing the same tune. How does that actually work under the hood?
It relies heavily on regular expressions, commonly known as regex.
Okay, regex.
Right. In a massive enterprise, different teams in different countries will have developed their own local naming habits over the decades. Let's say your European division built an interface and hard-coded the destination server name as EUWH01 for their warehouse.
Okay.
Meanwhile, the American team built an interface pointing to the exact same physical server, but they typed the destination in their system as Euro Warehouse Prop.
Oh, I see. So if you just run a dumb raw export of your systems, your spreadsheet is going to list those as two entirely separate destinations. You'll think you have two warehouses.
Exactly. The inventory will be bloated with duplicates and false endpoints. The WHINT Cockpit uses regex rules to computationally analyze those varying text strings, recognize the underlying pattern, and mathematically map those disparate sender and receiver names into a single, canonical, standardized definition.
That's clever.
It translates all the local, messy dialects of your disparate IT teams into one pristine, universal language for the map.
That mathematical normalization is crucial. But what really caught my attention in the white papers is a feature they call end-to-end flow visualization.
Oh, this is a big one.
Yeah, this suggests it goes beyond just a static list of endpoints. Is it actually tracing the specific journey of a single business process across all these different harmonized technologies?
It is. Think about how complex a modern transaction is. A customer clicks Submit Order on a website. That creates an API call. That call might hit a Microsoft Azure Logic app, which translates the web request and pushes it into a Confluent Kafka event stream. That stream is then picked up by SAP Process Orchestration, which finally converts it into an IDOC and drops it into the core SAP ERP database. That is 5 different architectural hops across 3 different software vendors.
And historically, if that order failed, 5 different IT teams would sit in a war room looking at their own isolated dashboards, pointing fingers saying, well, it left my system fine.
Precisely. The WHINT Cockpit pulls the metadata from all those separate systems, uses that harmonization engine we just discussed, and logically links the disparate steps. It generates a visual, traceable, end-to-end process flow. You could literally see the structural path from the web API all the way down to the database level.
And it doesn't just keep this incredibly valuable visual map locked inside its own dashboard. The architectural deep dive mentions robust enterprise architecture management, or EAM integration. It actively pushes the synchronized inventory data out into specialized EAM platforms like SAP Linux, LUI, HOPEX, and B360.
This specific integration is a massive strategic advantage for corporate leadership. Enterprise architects are the people tasked with designing the 3 to 5 year future of the company's technology.
Right. They need to know what they're working with.
Exactly. They map out the future state in tools like LeanX. But their biggest hurdle is that their current state baseline is almost always a guess. They have to beg integration developers to manually update them on what is currently running.
Which we established never works.
Never. By having the DEN cockpit automatically and continuously feed the empirically discovered inventory directly into these EAM tools, the corporate silos are obliterated. The architects are suddenly planning the multi-million-dollar future of the company based on hard, automatically verified facts rather than outdated assumptions.
Okay, so let's summarize where we are. We have successfully mapped the chaotic digital city. We have a perfect, auto-updating, harmonized, end-to-end map of every digital bridge, tunnel, and data stream. But having a map is only half the battle. You have to document it. Which leads us to the second major capability the sources highlight, ending the manual documentation grind.
Technical documentation.
Yeah.
It is the universally acknowledged chore of the software engineering world.
Here it is.
Everyone in leadership knows it is absolutely critical for regulatory compliance, security audits, and team continuity. And almost universally, every single developer despises creating it.
I think anyone listening, regardless of their industry, can relate to this. Think about the last time you were asked to write a standard operating procedure or a manual for how you do your daily job.
Oh, the worst.
Right. Not just doing your job, but explicitly detailing every single step, every exception to the rule, every edge case, and formatting it perfectly in a Word document. It is tedious, soul-crushing work. Now imagine doing that for highly complex code logic.
Yeah, it's exponentially harder.
And the worst part about integration documentation is that the second a developer tweaks one single line of code to fix a bug, that entire manual they just spent 3 days writing is instantly obsolete. Unless they remember to go back and manually update the Word document, which, let's be honest, they never do.
They rarely do, because they are immediately pressured to move on to the next urgent business request. The disconnect between the running code and the written documentation is a massive risk.
Yeah, I can see that.
If a senior developer leaves the company to take a new job, and their complex interfaces aren't accurately documented, their deep institutional knowledge simply walks out the door with them.
Poof, gone.
Exactly. When an external financial auditor comes knocking on your door 6 months later, demanding concrete proof of exactly how sensitive financial transaction data is routed through your network, telling them, "We think Sarah built it this way 3 years ago, but she's no longer here," that will result in massive compliance fines.
This is where the WHINT Cockpit seems to offer an almost magical quality of life improvement for engineering teams. It leverages that exact same automated inventory engine we just discussed. It takes all that discovered metadata, all the structural routing rules, the sender-receiver relationships, and the integration flow artifacts, and it automatically generates the human-readable technical documentation.
It entirely removes the human transcription error from the equation. It uses the actual living system configuration as the unassailable source of truth. The WHINT Cockpit automatically parses this metadata and generates comprehensive, perfectly formatted technical reports.
And it can export these as static PDFs, which are ideal for freezing a moment in time to hand over to a regulatory auditor.
Exactly. But static PDFs still get lost in email folders.
Yeah.
The fact sheets highlight that it goes a step further by utilizing add-ons to push this auto-generated documentation directly into the collaborative platforms the company's already using daily, like Atlassian Confluence or Microsoft SharePoint.
That is where the real daily value lies. The know-how becomes democratized and instantly accessible to anyone with the right permissions. The business value here is maintaining an audit-ready status at all times.
Yes, audit-ready is the key word.
You are no longer scrambling for 3 weeks before the auditors arrive, forcing your engineers to reverse engineer their own work. The documentation on the Confluence page is always a perfectly accurate reflection of the running landscape.
It's a huge relief for IT managers.
The source materials make a specific point to connect this automation to human psychology and organizational health, too. They explicitly state that by removing this manual documentation burden, employees can devote themselves to more important tasks, which directly leads to happy employees and managers.
It's a very real benefit.
I love this point. If you are paying top-tier salaries for brilliant software engineers, you want them engaging in creative, strategic problem-solving. You don't want them acting as overpaid typists, manually transcribing their own architectural diagrams.
It is a massive shift in how you allocate cognitive load. You are taking high-value human capital and redirecting it from low-value repetitive administration toward high-value innovation.
However, let me throw a wrench into this.
Okay.
Having perfectly automated, up-to-the-minute documentation is fantastic, but documentation, by its very nature, only tells you what is. It is a historical record. If your team built an incredibly inefficient, poorly designed, structurally unsound digital bridge, the automated documentation will perfectly and accurately record that you possess a terrible bridge.
That is a very fair point.
Documentation does not enforce quality.
You've hit on the crucial limitation of mere visibility. A map doesn't prevent bad drivers. How do we ensure that the integration landscape isn't just documented, but that it actually adheres to rigorous architectural standards? How do we ensure it is secure, efficient, and strategically aligned? This necessitates moving from passive documentation to active governance.
This brings us to the third core pillar detailed in the sources: governance, checks, and strategic alignment. And I want to be incredibly clear with you, our listener, about what this means in the context of the WHINT cockpit.
Yes, this distinction is vital.
When we talk about checks, we are strictly talking about architectural governance, structural design rules, and configuration validation. We are completely ignoring the concept of operational monitoring.
Right.
This tool is not a live dashboard with blinking red lights waiting to page an engineer at 3 a.m. because a server crashed. This is about deep, automated design governance.
Exactly. This is proactive quality assurance, not reactive operational firefighting. The WHINT cockpit enforces this structural governance through multiple distinct layers of automated checks. Let's examine the foundational layer: versions and naming checks.
Naming conventions. On the surface, arguing over how to name a file sounds like the most bureaucratic, soul-draining IT argument imaginable.
It usually is.
Right. But at the scale of an enterprise, it's the bedrock of sanity. If the logistics team in Germany names an interface D-shipping outbound V1, and the team in Chicago names an identical interface ship out US final, you have absolute architectural anarchy.
Without strict naming conventions, searching the landscape for vulnerabilities or redundancies becomes impossible. The WHINT cockpit automatically reads the names of every discovered artifact and validates them against the company's officially defined, mandated naming conventions using pattern recognition. It instantly flags any developer who deviates from the corporate standard.
And what about the version checks? The sources mention comparing artifacts across environments.
This addresses a massive source of system instability known as version drift. In professional software development, you have distinct environments. A developer builds the interface in the development environment, it moves to quality assurance for testing, and finally, it is pushed to the live production environment.
Right, the standard pipeline.
The nightmare scenario is when the code that was rigorously tested in QA somehow differs from the code that is actually running in production. The WHINT cockpit continuously compares the versions across these environments and highlights discrepancies. It ensures that the structural integrity of what was approved is exactly what is running live.
Let's go deeper into the actual code structure. The technical white papers specifically outline design checks for SAP Cloud integration content. They state it validates the content against defined iFlow design guidelines.
Yes.
Explain how a system automatically checks the design quality of another system's code.
Well, an integration flow, or iFlow, is essentially a visual and logical map of how a message is processed. It receives the data, maybe encrypts it, maps the fields, and sends it on.
Okay.
A robust enterprise will have strict architectural guidelines. For example, a rule might dictate that every single iFlow must contain a specific standardized exception subprocess.
Meaning a backup plan.
Yeah, a defined safety net for what the system should do if the data mapping fails, so it doesn't just silently drop the data. The WHINT cockpit parses the underlying XML or JSON configuration of these iFlows and computationally checks if those mandatory subprocesses are present and correctly configured. It acts as an automated, relentless architectural review board.
That is incredibly powerful for scaling a team. If you are outsourcing integration development to an external consulting firm, you don't have to manually review thousands of lines of their work. The cockpit automatically ensures that every consultant's work adheres to your exact internal gold standard.
And it elevates governance even higher to what the sources call integration strategy fit. This is where IT aligns with corporate security policy.
Give me a real-world example of checking strategy fit.
Let's say the Chief Information Security Officer mandates a new global strategy. We are officially deprecating all old-school basic authentication, meaning simple usernames and passwords across all interfaces because they are too easily compromised. Every connection must now use secure, encrypted, certificate-based authentication.
Finding every single password-based connection hidden in thousands of interfaces manually would be a nightmare.
It would take months. The WHINT Cockpit, because it already has the deep configuration metadata, can instantly run a validation check across the entire landscape. It looks at the specific adapter usage and authentication methods of every single interface, and it instantly flags any endpoint that is still using basic authentication. It highlights the strategic outliers immediately.
Okay, so it enforces naming rules, design quality, and security strategy. But the feature in this section that absolutely fascinates me is decommissioning and cost allocation.
Ah, yes, the financial side.
The sources state that the cockpit tracks specific KPIs to find dead or unused interfaces, actively flagging decommissioning potential. If we go back to our city analogy, it sounds like the WHINT cockpit acts like an automated Marie Kondo for your digital infrastructure.
I love that comparison.
Yeah, it scans the city, finds the bridges that no one has driven a car over in 2 years, and actively helps you tear them down. Does it spark joy? No. Tear it down.
The Marie Kondo comparison is highly accurate because the underlying philosophy is about removing the unnecessary to improve the whole. Identifying technical debt and redundant systems is arguably the single fastest way for a chief information officer to save tangible money.
Explain the economics of that. Why does an unused interface cost money?
Every interface that exists, even if it was just sitting there waiting for data that never comes fill, consumes resources. It consumes cloud compute power and memory. It often consumes expensive software licensing fees based on the number of active connections. And perhaps most critically, every forgotten interface is an open door that no one is watching. It is a massive cyber hygiene risk.
So if you have an old API connection built for a third-party vendor that you stopped doing business with 3 years ago, and that connection is still active and listening on your network, that is a prime target for a data breach.
Exactly. Actively decommissioning unused interfaces reduces your cloud spend and significantly shrinks your attack surface. Furthermore, the cockpit tackles the financial black hole of IT spending through cost allocation. Because it understands the metadata, you can tag and group these interfaces by specific business domains, geographic countries, or corporate brands.
Oh, I see. Instead of the IT department just presenting one massive, terrifying monthly cloud bill to the board, they can look at the map and definitively say, the logistics department in France is driving 40% of our integration infrastructure costs.
Yes. It shifts the integration landscape from being a mysterious, unquantifiable technical burden into a transparent, financially accountable business service. The source materials include a very telling quote from Winfried Winterstein, the team leader of SAP technology at Döhler, a major global producer of natural ingredients.
What does he say?
He notes that the WHINT solution helps them maintain total transparency over their SAP cloud integration content, keeping them constantly informed about their structural status. It's entirely about bringing the invisible, expensive infrastructure into the light so it can be managed like a true business asset.
All right, let's take a step back and look at what we've assembled here. We have a ridiculously powerful architectural tool. It automatically discovers every connection across multiple vendor clouds and on-premise servers.
Sure.
It writes perfect, audit-ready documentation without human intervention.
Sure.
And it relentlessly enforces architectural governance, security strategy, and cost-saving decommissioning rules. It sounds perfect. But, and this is a massive but, before any enterprise IT manager, and certainly any chief information security officer, allows a third-party SaaS tool to spider through their entire corporate network and map out every single data flow, they are going to demand an answer to one screaming, non-negotiable question.
The data privacy question.
Yeah.
Is my highly sensitive business data safe?
Exactly. If this tool is analyzing the flow of data across the entire company, what happens if I am a global banking institution or a massive healthcare provider handling patient records? If the WHINT cockpit gets hacked, does the hacker get all my credit card numbers and medical files? This brings us to a crucial section of the source material, under the hood, data privacy and deployment options.
The white papers anticipate this exact enterprise paranoia, and they address it with one fundamental, architecturally enforced rule. The crucial distinction is this. The WHINT Integration Cockpit does not and architecturally cannot persist any business data.
Let's break that down. When you say business data, you mean the actual payload. So going back to our physical mail analogy, if my IT network is the postal service, the cockpit is looking at the outside of the envelope.
Right.
It It reads the return address, the destination address, the weight of the letter, the type of stamp, and the routing barcode. But it never, ever tears open the envelope to read the actual letter inside.
That analogy is technically perfect. In networking terms, it only extracts and stores the configuration metadata. It catalogs the structural identification, the names, the unique interface IDs, the version numbers. It tracks the lifecycle information, such as which developer modified the configuration last and the timestamp of that change. Okay, so it sees the framework. It maps the structural connectivity, the sender and receiver system names, the protocol types, and the URLs. It even looks at the logic scripts that dictate how the envelope should be routed. But the documentation explicitly guarantees no payloads are ever read, no actual message content, no credit card strings, no names, no financial balances is read, intercepted, or stored by the WHINT cockpit.
That distinction is monumental for regulatory compliance. If you are routing highly restricted GDPR data or high-pay protected health information through your SAP system, the cockpit has absolutely zero visibility into that payload. It only knows that Interface A successfully transmitted a structured packet to Interface B based on Rule Set C.
This metadata-only approach solves a massive headache in modern enterprise SaaS adoption. For years, European companies were terrified to utilize cloud-based management tools because of the strict data residency and privacy laws enforced by GDPR.
Right. Sending data outside the country was a huge no-no.
By strictly limiting the tool to metadata analysis, you bypass those massive data liability hurdles entirely. You achieve total architectural governance and visibility without ever assuming the risk of hosting the client's actual business data.
But even with that airtight metadata-only approach, the sources show that whitepaper.id GmbH doesn't force a one-size-fits-all deployment. They offer a highly flexible variety of deployment options to satisfy the differing paranoia levels of various corporate security postures.
Flexibility is a necessity in enterprise software. The standard lowest friction offering is the pure SaaS model. In this scenario, whitepaper.id GmbH runs, hosts, and maintains the application for you in their own secure SAP Business Technology Platform, or BTP subaccount. You simply log in via a web browser and utilize the tool.
But what if you are a highly conservative financial institution and your internal security mandate dictates absolutely no external third-party cloud tools are allowed to hold our architectural map? It must live inside our own tenant.
For those organizations, they offer the second option.
Yeah.
The bring your own subaccount model.
Okay, how does that work?
In this architecture, whitepaper.id GmbH deploys the WHINT cockpit application directly into the customer's own pre-existing SAP BTP environment. The data and the application run entirely on the customer's own database.
Oh, that's smart.
The technical specifications detailed in the sources are precise for this option. The customer must provision a specific Cloud Foundry runtime environment with adequate memory, and they must utilize a robust PostgreSQL database on the hyperscaler option to handle the complex relational mapping of the metadata.
So it leverages the infrastructure the company has already vetted and paid for. And for the truly extreme cases, perhaps highly classified defense contractors or deeply isolated government entities, there is a third option.
Yes. The bring your own on-premise option. If you operate in an entirely air-gapped environment or a strictly private local cloud, the application can be deployed locally.
Wow.
This deployment triad SaaS, customer cloud, or on-premise is a masterclass in removing barriers to entry. The tool sets up in hours, it never touches the toxic payload data, and it can be hosted wherever the strictest compliance officer dictates. It is a profoundly pragmatic approach to solving a deeply complex engineering problem.
Pragmatic is the perfect word to summarize this entire deep dive. What we've explored today isn't about flashy generative AI gimmicks or vaporware. It is about fundamentally solving the unglamorous, terrifyingly complex foundational plumbing of global enterprise IT.
We are looking at a necessary industry-wide paradigm shift, moving from a state of manual reactive chaos to a state of automated proactive order. The WHINT Integration Cockpit acts as both the cartographer, relentlessly mapping the digital city, and the strict building inspector, ensuring every new structure is built exactly to code.
Beautifully said.
By fully automating the inventory discovery, completely removing the manual burden of technical documentation, and strictly enforcing architectural governance, it systematically eliminates the technical debt that cripples corporate agility.
And as a listener, why does this deep dive into enterprise integration matter to you? Why should you care about metadata and SAP APIs? Because even if you have never written a single line of code in your life, your entire modern existence relies on this infrastructure.
It really does.
When you log into your company's HR portal to check your healthcare benefits, when you track a global shipment of raw materials crucial to your business, or when you collaborate seamlessly with a team sitting on another continent, your ability to do your job is completely 100% dependent on that invisible spaghetti of interfaces not breaking. Tools that govern this complexity are the unsung heroes keeping the digital economy turning smoothly.
Knowledge is most valuable when we understand the systems that govern our reality. Demystifying the complexity of enterprise systems, realizing that this chaos can actually be mapped, governed, and tamed, rather than just accepted as a dark art managed by stressed developers, is a deeply empowering realization for any professional.
I completely agree. And I want to leave you, our listener, with a final, slightly provocative thought to mull over as we sign off. We've spent this time discussing how this tool acts as an incredible automated mapmaker and a rigorous architectural inspector. It maps the logic of how global systems communicate, and it validates that the existing bridges are built to the correct specifications.
Right.
But if we already have a tool that can perfectly map the terrain, understand the mathematical rules of engagement, and digitally validate the complex logic of integration, how far away are we from the next logical step?
Oh, I see where you're going with this.
How far are we from an artificial intelligence that doesn't just read the map and highlight a missing connection, but actually writes the code, provisions the security certificates, and automatically builds the bridge itself based on these governance rules?
If you perfect the blueprints and enforce the building codes through automation, the actual physical construction of the digital bridge is the inevitable next candidate for total automation. It is a fascinating and perhaps slightly intimidating horizon for software engineering.
It truly is. Thank you for joining us on this deep dive into the hidden architecture of our digital world. Remember, knowledge is power, especially when it gives you the ability to see and understand the invisible systems running the metropolis. The next time you click buy and expect a seamless transaction, take a brief second to appreciate the beautifully complex, heavily governed digital city that instantly springs to life to make it happen.
How mature is your organization when it comes to integration topics? Find out for free with our Integration Maturity Assessment at whint.co/IMA. That's WHINT.co/IMA. In case you want to take control of your integration landscape to increase transparency and automate your integration quality processes, please schedule a call at whint.co/contact. If you enjoyed the content, please like and subscribe to our podcast. See you next time.